Hey there, in this video we're going to talk about slicing, which is something we can do to strings, lists, and tuples. It's a way to get the individual contents of these objects. So for example, slicing a string will give us individual letters, and slicing a list will give us individual elements of that list. The syntax for strings, lists, and tuples is all the same. So we're going to start with strings because it's a little bit more, I think, easier to understand with a string. Let's create a string S and let's call it hello. Let's spell it right too. Okay, and in there we have the letters H-E-L-L-O. And let's make sort of a map of what's in here. Okay, so we've got H-E-L-L-O. Okay, and I put these bars in here just to help separate the characters. We can sort of think of in our computer's memory, some space has been set aside for H, and then next to it some space for E, L, L, and O. Okay, and then let's name these different partitions. So 0 is right before the first letter, and then we have 1, 2, 3, 4, 5. Okay, so thinking about this division right before the first letter will help us picture what's going on with slicing. So now if I ask for the 0th element of this, that means I want to look right here. Like what's right after this? Well, that's H. So it's going to give me H. If I look for index 1 here is actually the second element. So it's right after 1, gives me the E, okay, and so on. All the way out to 4, which should be O. What happens if I ask for 5? I get yelled at because I'm asking for something past the end of the string. Python won't let me do that. There are some languages that do let you do that, and you get to find out whatever weird stuff lives beyond your string, and that usually results in something crashing. But Python just says, no, you can't even look there. We can also extract a range of letters out of our string. And so the syntax for that is pretty similar, except we put a colon in between the start and the stop. So if I want to slice from 1 to 3, okay, that's going to be start at 1 and then end at 3. So 3 is going to be right there. We're going to get H-E-L. We could also go slicing 3 through 5. This is okay, because it's going to go up to 5. There's letters there. I can't go past 5, but I can go up to 5. That'll give me the L-O at the end. I can, in fact, leave out the 0, or I could leave out the 5. So if I just do a :3, this defaults to starting at 0, starting at the beginning. So this says slice up to 3, H-E-L. The other version of this is slice all the way to the end. So slicing from 3 all the way to the end is going to be L-O. I can even slice negative numbers. So if I ask for -1, what that means is it starts counting from the right. So if I go -1, it's just going to give me the last thing. It's going to be the O. If I ask for -2, it'll be the second to last thing. It'll be the L here. So we can count from the right by using negative numbers. -1 is really handy if you know you want the last thing. Now in a string like this, I wrote out the letters, I counted them. What if I don't know that? I'm passed some string from somewhere else in my program, or I read it from a file. How do I know how long it is to make sure I don't try to slice past the end? The solution there is to use the built-in function length, spelled L-E-N. So if I ask for the length of S, we're going to see that S has a length of 5. Like the last index here is 5. I can't ask for the contents of 5, but I can go up to 5. There's 5 things in it. 1, 2, 3, 4, 5. So slicing lists and tuples is exactly the same. Just a quick one here. So let's say 1, 2, 3. If I want to know what is L0, same kind of syntax. If I want to slice all the way up to 1, that's the same thing. It's just asking for 0. If I want to slice up to 2, 1 and 2. So exactly the same as the string. There is a difference, though, between strings and lists. And that is that lists are mutable. That means you can change them in place by using assignment. You're not allowed to do that with strings, and you're not allowed to do that with tuples, but you can do it with lists. So if I come back to my string here, and I try to say something like, I want to change the first letter of hello to J to spell jello, I'm not allowed to do that. It says you can't do that. It says, oops. Well, here it's telling me that J is undefined because I didn't put quotes around it. But if I say, even with quotes, it's going to yell at me because it says string object does not support assignment. However, I can take L0 and I can change that. Let's put a 3 in the beginning of that. And now L starts with 3. In fact, just to be stubborn, I could put a J in there too. There's no reason that a list has to have all the same sort of variable in it, although usually it would to be meaningful. So I can change lists in place because lists are mutable. I'm not allowed to do that with tuples. I'm not allowed to do that with strings, but I can do it to a list. So being changeable in place can be very handy. That's kind of a powerful thing, but it's also a little bit confusing, a little bit dangerous. For example, let's create a list, and that'll be equal to 1, 2. Now let's say B is equal to A. Now I'm going to set B equal to 3, 4. So my question is, if I run this code and I print A, what am I going to get? Have I changed A by changing B? The answer is no. So what's happened here is I've created the name A and I've assigned it to this list 1, 2. And then I've said, well, let's let B be equal to the same thing as A. And then I said, you know what, never mind. I want B to be something else. Let's make B equal to 3, 4. So if we just make a quick picture of that, it's a lot like just working with X's and Y's and individual numbers. So far, nothing weird actually. So I take A and I assigned it 1, 2. And when I say B equals A, I say, oh, I want B to be equal the same thing as A. So for a moment, they are the same list, but then I change what B is. I make it something different. And I remove the previous reference. Okay, now let's make C equal to A. And let's change the first element of C. Let's make it equal to 0. Have I changed A? The answer is yes, I have changed A. Well, why is that? Well, I've made C be the same thing as A. It's pointing to the same thing as A, and then I changed that thing. Well, since it's the same thing, since I point at the same thing, that means when I look at A, the contents have changed. Coming back to our picture. I say C equals A. I make C point at the same thing as A. And then I run the command index C and make it 0. It says, all right, go up here. This isn't 1 anymore. Now it's 0. And both C and A refer to that same thing in memory. And so there I have made a change. It's not the same as the previous example where we redefined what B's name referred to. Here I haven't changed what the name C refers to. I've changed that thing itself. We didn't see this before with single variables because you can't change a number in place. Numbers are also immutable. You can't change 2 to B3. 2 and 3 are different things. But you can change a list in place. And so that can be really kind of confusing. This is true even if you're passing them to functions. So let's make some new names. Let's make D is equal to, let's make it 9, 9. And I'm going to create a function, call it changer, and I want to give it some list L. And then changer's job is to take list L and change whatever the first thing in that list is to -1. Okay, and so I'm going to run changer and I'm going to give it D, and then I want to print what has happened to D. Well, it's been changed. So even though D lives outside this function here, and it should be safe from just the regular scope rules, it's only safe in the sense that its name is safe. But I pass in this D here, and it refers to the computer memory that holds 9, 9, and then I say, oh, I want to change some of that memory. Well, that change is permanent. That change is reflected outside. So if you weren't expecting that and you pass an array to a function and then your function changes the array and then you use the array later, there can be lots of tears and bad times. So just be aware of that. There is a way to protect yourself from this. You can do a redefinition in here. You can say L is equal to L.copy. So what this will do is it will make a copy of whatever L is and then rename L to that copy. So now you have separate computer memory. If I run that code, then D is not changed. Okay, so remember that copy can save you, especially when we start doing some linear algebra later in the course, where you'll pass arrays, which act a lot like lists in this sense. So you pass an array to a function, you want to be careful that your function doesn't change the array itself. You want it to give you some kind of mathematical result without messing up whatever you passed to it in the first place. Okay, so in this video we talked about how we can slice larger objects, strings, lists, tuples, and then later on arrays will be basically the same syntax. And we've learned about the difference between mutable and immutable. Mutable is kind of cool because you can change things in place, but at the same time, you got to be a little bit careful that you aren't surprising yourself with the change.